Good morning and welcome to the fifth event in the COLS ESG webinar series, kindly sponsored by Savills. My name is Ami Kotecha. I'm a committee member at COLS and lead on our ESG program. Thank you for joining us bright and early this morning. And despite or because of the victory of yesterday, we don't have any extra time when it comes to climate change, and that's why this topic of carbon sequestration is as important as it is. I'm pleased to welcome our panelists who have joined us this morning to discuss this topic, and specifically the potential of nature-based and technology-based carbon capture and storage solutions to become a part of our response to our climate change and to our carbon neutrality strategies. Our panelists will firstly provide a broad overview of the solutions that are available, and then, using their experience and insights, consider the potential of these solutions for offsetting the hard-to-abate residual emissions that may become part of our net zero plans. Typically, in the built environment sector, we would expect these residual emissions to be attributed to the embodied carbon component that forms a significant part of our building's life cycle. And then our panelists will hopefully move on to consider the commercial viability of CCS or carbon capture solutions as an opportunity for land use to support a wider carbon neutrality for other sectors, such as aviation and shipping, for example, that may have a need to consider CCS as part of their pathways to net zero. I would now like to introduce our expert panelists, each of whom brings a significant amount of expertise to this topic. Firstly, Dr. David Reiner is a university senior lecturer in technology policy at the Judge Business School at the University of Cambridge and assistant director of the Energy Policy Research Group at Cambridge. His research focuses on energy and climate change, politics, policy, economics, regulation, and public attitudes. Next, I'd like to introduce David Gardner. David has been CIO Forestry and a member of the Forestry Investment Committee at Gresham House since May 2020. He joined the firm from Global Forest Partners LP, a US-based timber management and investment company, where he worked from 2009 to 2019. David is responsible for developing the company's international growth and for supporting the management of their existing forestry investments. Next, I'd like to introduce Angela Hepworth, who is Commercial Director for Innovation at Drax, where she is helping the company deliver its ambition to be the world's first carbon negative power station and a major player in the energy transition. She is focusing on the development of bioenergy with carbon capture and storage, BECCS as it is called, at the Drax Selby site. Lastly, I'd like to introduce Michael Evans, who is a serial entrepreneur and innovator and an active lobbyist on industrial and climate change policy. He has founded a number of clean tech companies, including CMR Fuel Cells, which was floated on AIM, and also Green Tide Turbines Limited, a developer of tidal turbine technologies. He's now CEO of Carbon Capture Technologies Limited, a startup developing game-changing CO2 capture and mineralization technology, permanently converting CO2 to valuable mineral byproducts. Their extensive bios will be on the chat function later or will be provided by Savills. This event is being recorded, and I'd like to ask that you take part in the live Q&A, live question and answer session at the end. Now over to David Reiner, our capable moderator for the event, who will take this discussion forward. Thank you so much.
Great, thanks so much. I mean, and thank you everyone for joining us. This is obviously a very important topic, and we have a great panel. Just to be clear, there is a Q&A, and so please do use the Q&A box rather than the chat box for any questions that you have along the way. We won't be taking questions for every talk, but I'll be monitoring it, and we'll be consolidating things as we go along. So if we can go to my first slide, I just wanted to say a few words about some of the research that we've been doing on this very important topic of CO2 removals and these two alternative pathways to negative emissions, which would be either so-called engineered removals or more nature-based removals. So next slide, please. So we do a regular sort of annual surveys of the UK population. This is carried out by YouGov for us, and we're lucky enough that we have very recent data from just a couple of weeks ago that we've commissioned, and you know, we can hold in abeyance the question of how important the UK public is in terms of influencing policy, but it is striking that certain options are very popular. So afforestation or reforestation is consistently one of the most popular options with very little opposition. Solar energy similarly is very popular. When you move beyond that, then there's either more uncertainty or potential pockets of opposition, even for things like wind energy or bioenergy. But again, we do see certain engineered removals with greater uncertainty and at least some divisions amongst the UK public as to you know, their use going forward. That said, if that's not an option, then some of the kind of other options like geoengineering are even significantly less popular, like injecting aerosols into the stratosphere or ocean iron fertilization. Next slide, please. So one of the other things that is striking, and as I mentioned, we do this on a quite regular basis, many of the views of the UK public, say on solar or afforestation, are really quite stable. The fact that we should be using more clean energy, again, is also very solid in terms of, this is kind of data from 2013 through to our most recent survey, with, you know, about 50% naming it as one of their top 3 priorities for government to be focusing on. The one area where actually there has been notable increased support amongst the UK public actually has been this red line, which I'm not sure if you could read it, but it says ways to remove carbon dioxide from the atmosphere. And so again, in the context of these longer term trends, I think that is quite important that there has been increased sort of public attention to these issues that we'll be talking about today on the panel. Next slide, please. And then finally, and this will be issues that come up over the course of the panel and hopefully in the Q&A as well. You know, a critical question in all this is the permanence of these solutions. And one of the questions we asked was to say, and we broke the sample into half. So we asked half of them the question that you just see in front of you in black, which talks about the importance of storing CO2. And maybe not surprisingly, a lot of people said they didn't know, but there was a strong preference for using trees versus the so-called engineered solutions of storing the CO2 in rock formations. On the other hand, for the other half of the sample, for the other 1,000 respondents that we asked, and we gave them just a little bit of information, telling them that you know, the CO2 stored in wood will last maybe 100 years, and the CO2 that would be stored in the rock formations would be stored for some 10,000 years. We actually see a statistically significant shift to you know, amongst those, you know, the half of the public that was informed that actually, if you're storing CO2, it might be more attractive if it's stored for longer periods. Anyhow, these are the sorts of issues that we'll be tackling in our discussion. So without further ado, I'll turn the floor over to the next panelist, which is David Gardner.
Thank you, David. That was a great lead-in. And I'm David Gardner, CIO of Forestry for Gresham House, and I'd like to sort of talk about the case for commercial forestry. And that was a great lead-in, that forestry is seen as being an important nature-based solution. And I really want to stress that it is a viable opportunity for land use. Next slide. And next slide. And so Gresham House is a specialist asset management group. And in the context of this discussion, we are the largest forestry asset manager in the UK. And we do have other forests around the world under management as well. And I think this sort of leads to the fact that we have around 140,000 hectares of forest in the UK alone, sort of shows that forestry is a commercial and viable way of using the land. Next slide. Now, of course, we are in a climate crisis. And my first point here is that we actually need to look at every solution. You know, there is not one right or one wrong. This is a problem that needs every solution that we can find. At the moment, if you look at the chart, you can see that afforestation, reforestation is one of the lowest cost technologies for carbon storage. Not only is it low cost, but it also has a very big potential for locking up carbon around the world. And that's clearly shown that it is also commercial, in that it's more than $100 billion has been invested in forestry by institutional investors. Next slide. I want to talk a little bit more about carbon sequestration. And if you look at the chart, you can see that different trees lock up carbon at different rates. The blue line on the chart shows a commercial conifer crop in the UK. And the green line shows sort of natural broadleaf woodland. And you can see that the rate of carbon sequestration is much higher in the commercial conifer crop. There is a quirk in the carbon accounting rules, which really works against commercial forestry, and the fact that all the carbon locked up in the timber is seen to miraculously sort of disappear once it's felled and harvested. And that means, you know, and often there's a perception because of that broadleaf woodland is actually a better carbon solution than commercial conifers. Where does all that wood go? The next slide. That wood generally will go into residential and commercial construction. And not only is the wood stored for relatively long periods of time, maybe 30 to 100 years lock up in the buildings, but the more wood you put into a building, the lesser amount of other high carbon intensity products get used, particularly cement, steel, and aluminium. And if you look at this example here of a city in Helsinki, where 4 similar 5-story apartment blocks, 2 in wood and 2 with concrete, were built, the production of materials used in the timber buildings had about a 74% lower carbon footprint. So what we are seeing is that wood is starting to get recognized as a way of reducing the carbon intensity of construction, which is a big carbon emitter. Next slide. So looking at more holistically around carbon sequestration, in this study, there was a look at various commercial management of forests versus sort of conservation forests. And if you take a look at the far left-hand bar, you can see this is a commercial conifer crop in the UK. And you can see, of course, there is some emissions from the harvesting and transport and production of the timber. And then all those different colors below the 0 line show the sort of holistic lockup of carbon from that crop. And you go across to the semi-natural conservation side, and you can see this is a broadleaf forest in the UK in a sort of similar terrain. Of course, there's no emissions. And you can see if you just look at the trees, the net sequestration probably is in favor of the broadleaf conservation forest. But of course, if you look at it holistically, then commercial forestry is a far more efficient way of locking up carbon. Of course, we need both. I'm not saying that there should be one or the other. Next slide. Afforestation is a big issue around the world. Targets of afforestation and new planting have fallen, you know, just generally around the world. And this is particularly in the case of the UK, where you can see the government target of 30,000 hectares there. That target hasn't been achieved since around 1980 or so. So, you know, it is an issue, and it's being tackled, and there's a big focus from the government side. And commercial forestry has its place. And commercial forestry these days is regulated so that, of course, there is a level of biodiversity in it there is, most of our forests would be somewhere around 60% planted with commercial crop, and about 40% would be open area or broadleaf forest. And so what is important here, and for the UK and around the world, is that more trees are planted, both from a commercial point of view, but also to fulfill net zero targets. I think that will give some comment and debate and questions, and I look forward to that. I'll pass you over to the next panelist. Thank you very much.
Good morning. So I'm Angela Hepworth, and I'm the Commercial Director for Drax. And my focus today is looking at engineered carbon removal solutions, and in particular, bioenergy with carbon capture and storage. So if we go on to the first slide. Now, I don't think I need to dwell on this because this slide is really making the case for carbon removal technologies in achieving net zero. And I think that's been spoken about already. We're going to, each sector of the economy needs to do everything it possibly can to reduce its emissions as far as possible, but there will still be residual emissions that need to be addressed with carbon removals. And the chart on the right-hand side is taken from the Climate Change Committee's recent report, which sets out the scale of likely residual carbon emissions and therefore the need for carbon removals, the black part on the chart, in order to address those residual emissions. So if we're going to achieve net zero alongside decarbonisation, it's essential that we have carbon removal technologies. Next slide. Now, as I say, I'm going to focus on one technology in particular, which is bioenergy with carbon capture and storage. So if we start off with a description of what BECCS is. Now, the BECCS cycle starts with sustainably managed forests capturing CO2. And I would very much echo David's comments about the benefits of sustainable forestry as a way of removing CO2 from the atmosphere. I mean, we've got a similar evidence base that we look at, which shows that if you have sustainably managed forests, actually they can be a more efficient, a more successful way of removing CO2 from the atmosphere than just letting trees grow under their own steam. And we have very stringent practices to make sure that all the wood products we use come from sustainably managed forests. And again, as David said, a lot of these, the forestry is used to support industries such as construction, but there are residual wood products that are left over, and some of those residual wood products and waste wood, if you like, is turned into wood pellets, which are then burnt in our power station to generate renewable power. So we take byproducts from the forestry industry, turn it into wood pellets, and that's what we use to produce our power. Now, we've been at the Drax site, we've been using biomass power for many years to generate electricity, but what's new is this idea of fitting carbon capture and storage onto the power station such that you can take the CO2 and store it permanently underground. And the point about permanence is a really important one. The solution that we're looking at here involves transporting the CO2 via pipelines offshore and storing it in permanent geological stores offshore. And the government is in the process of developing a series of CO2 removal clusters around the UK, and that's how we'll be storing our CO2. So if you look overall at what's happening here is we're taking the CO2 from the atmosphere via forestry and wood pellets. That CO2 is being stored permanently underground. Right, next slide. So this slide, again, the chart is taken from the Climate Change Committee and shows the role that the Climate Change Committee see for carbon removal technologies, including bioenergy, in achieving net zero. And you can see that the Climate Change Committee in its central scenario estimates that by 2050, we're going to need around 57 million tonnes of negative emissions. And of those 57 million tonnes, around 19 million tonnes should come from BECCS in power, which is the technology that I've just been talking about. And you can see with the chart on the right-hand side that the Climate Change Committee see that there's an urgency. We need to really ramp up these technologies. These technologies are mostly available now. They need to be deployed from the mid-2020s and then ramp up significantly to achieve scale, the necessary scale in 2050. Next slide. So this is some analysis that Drax has done, looking at why it's right to support bioenergy with carbon capture and storage if you compare it with the alternatives. So we got some economic consultants, Beringer, to have a look and say, well, if you were trying to decarbonise with and without BECCS and with or without the project at our power station, what's the cost difference to the UK? And the analysis that they did said, well, if you are not deploying BECCS in the late 2020s, as we're proposing, then you're going to be much more reliant on even more deployment of renewables, but also more measures in the decarbonisation of heat and transport, which are difficult to achieve and rely on individual customer action. We're going to need masses of that already, but if you don't deploy carbon removal technologies like BECCS, you're going to need even more of it, and it's going to cost you about £4.5 billion more for the UK to achieve its fifth carbon budget in 2028 to 32. So BECCS is a cost-effective way of decarbonising, and in fact cheaper than the measures the UK would have to take if it was to try and decarbonise without it. Next slide. So where are we now? We've been piloting the technology on our site up in Yorkshire at Selby. We've had a pilot plant extracting the CO2 from the flue gas. That's been running successfully for about a year. So we've proved that the technology works. And what we're looking to do now is to fit the CCS technology to the power station and have it up and running by 2027. That's our ambition, is to have the technology operational by 2027. And we're looking to do this to 2 of the units on the site. Each unit will capture 4 million tonnes of CO2. So cumulatively, it would achieve 8 million tonnes of carbon removals when we've got both units up and running. And this would make Drax the world's biggest carbon capture project, which is quite exciting. So BECCS has tremendous potential. It's clear that we need carbon removals. BECCS is a sustainable and economic way of doing it, and it is ready to deploy and hopefully will be operational by 2027. Thank you. I think I'm now passing on to Michael. Oh, I think have I managed to miss my last slide? My last slide. This is about how we might sell carbon removals, and this to me is quite an exciting aspect of all of this. If we think about how we've been achieving decarbonisation to date, a lot of it has relied on government support, with money either from electricity consumers or from the government itself. When we think about how we support carbon removal technologies, one of the exciting things is that there are more and more corporates who are making net zero commitments who want to buy carbon removals, and there's real potential there for corporates to be putting money into carbon removal technologies in order to meet their own net zero claims. And we've had, for example, Microsoft. Some of you might be aware that Microsoft last year procured a large volume of carbon removals, and we're seeing more and more companies doing the same. And it does raise some really interesting questions about how you maintain quality and how you make these market structures work. But I think it's a very exciting development that we're seeing more and more companies setting their own net zero targets, and that's a way of stimulating the carbon removal market. At which point that definitely is my last slide, and I shall hand over to Michael. Thank you.
Sorry, I had myself on mute there. Hi, I'm Michael Evans, CEO of Cambridge Carbon Capture, and I'm presenting to you today our solution for getting to net zero. It's basically capturing CO2 and converting it into mineral products which have an end use, potentially as a construction material. So it could replace products like gypsum in things like plasterboard, use it in fillers for construction materials like construction blocks, or in ready mix. Next slide, please. Yes, so I think we're all familiar with the problem. You know, the major issue really is that you know, these sort of technologies to get to net zero are really expensive, and currently there's no economic drivers to motivate industry to invest in them. This is obviously changing, and new sort of strategies are being developed through policies, etc., which is all very interesting. But currently, you know, there's no real incentive to capture carbon, and massive investment is needed to reduce to net zero. And without these incentivizations, this investment will not happen. Next slide, please. So we've developed a technology called Co2 Lock. It's a two-stage technology. So stage one is basically producing a material that can be used in stage two to capture CO2 in the form of magnesium carbonate, which, as I said before, is potentially a construction material. So stage one starts by using potentially mining tailings. So this is material that's already been sort of processed in mine sites around the world. Or directly using serpentine or olivine mined specifically for this purpose. So our technology splits the bond between the magnesium and the silicate that are in these materials, but it also liberates the metals that are also contained in relatively small quantities, but significant quantities within these materials. So at stage one, we can sell silica, and we can sell the metals. And we also sell the magnesium hydroxide to our customers who would be deploying our stage two technology. So in stage two, we're taking magnesium hydroxide, mixing it with water to form a slurry. And in much the same way as SOx is removed from the emissions from coal burning using desulfurization technologies, we can capture CO2, NOx and SOx using exactly the same sort of techniques and plant to store it as a magnesium carbonate. This is then just sort of dewatered, water returned back into the system, and the magnesium carbonates sent off to a construction company to be manufactured into products. Next slide, please. What's really unique about our process is that all the way down the line, we're producing byproducts that have value. And when you add up all the value that we generate, minus all the costs, we're making significant amounts of money. So we've worked out that for every ton of CO2 that we capture, we can actually create value of over £300 per ton. And this is a complete sort of flip from the situation I explained at the beginning. If our technology can actually demonstrate that you can make profits from capturing CO2, the profit incentive can then really drive this technology to be fully deployed and rapidly deployed across many, many different industries. Why wouldn't you? You're making money. Next slide, please. As well as making money, we're capturing CO2. So you know, this is our life cycle analysis. And when you start, you know, obviously it's a process, it's using energy, but we're also capturing CO2 throughout the process, both in stage one and stage two. And the net effect is that for every ton of CO2, it costs in energy terms 363 kilograms of CO2 to actually capture that ton of CO2. Now, if you compare that to other technologies, the sort of technologies that Drax are deploying, for every ton of physical ton of CO2 that's stored underground, about 500 kilograms of CO2 equivalents is released. So you're getting only half the benefit of that. So obviously you need to store 2 tons of CO2 to get your 1 ton of credit. So that's how that would work. So ours is better than the incumbent technologies. But when you start including the CO2 emissions that are saved through displacement of the materials that we produce in our process, we actually make an additional 591 kilograms of CO2 savings on top of the 1 ton that we've stored. So potentially it's a really, really positive sort of carbon benefit from our technology. Next slide, please. So we've been looking at a number of different applications of our technology. The obvious one, which is applicable to companies like Drax, would be the stripping of CO2 from industrial processes and power stations. We're also involved in looking at the production of hydrogen from natural gas. So there's a policy now to take methane, convert it to hydrogen, releasing the CO2 before it's combusted, and capturing that CO2 and storing it. We can also use it for cleaning up gases like biogas. Biogas contains about 25% CO2. That needs to be removed in order to get the value from the gas, and obviously materials productions like the metals, etc. Next slide, please. Yeah, so in summary, we have a technology that is essentially a circular economy solution to climate change. It's easy to deploy and offers a permanent home for the carbon that you've captured. It also is profitable, so has a potential to be rapidly deployed across the whole world. Every industrial process this could fit. There's no exceptions. So with that, I'd like to pass it on to the next presenter. Thank you.
Great, I think that's, I think that we're done. So if the panel could return. There we go. Just need Angela. Angela, you are there. Oh, there you go. Brilliant.
Yes.
Good. Well, welcome back, everyone, and thanks so much for I thought some excellent presentations, even given the very short time allocated to everybody. And we have obviously quite a bit of interest already being generated on the I should say the Q&A. There are a couple of questions in the chat, which I encourage people to, which I will kind of pose those eventually. But if people do have any questions as we go along, please do include them in the Q&A. Before I turn to those, maybe I wanted to ask a bit more, or drill down a bit more on an issue that I think you've all touched upon, but that is to do with sort of commercial viability and the question of, you know, what is needed. To, you know, clearly there will be some role, you know, important role for government, but, you know, in the context of each of your kind of individual cases, you know, what is the maybe, if you want, the kind of the short term and then the kind of medium to longer term signals, you know, what are you looking for to reach commercial viability? Maybe we'll start with as we started in terms of panels, or David first, then Angela, then Michael.
Thank you, David. So in terms of forestry, you know, in the past, government was actually the main driver for afforestation. Just about around the world, it was governments that were doing all the planting, particularly after the sort of post-war period where timber was needed to sort of rebuild after the war. And that sort of carried on for some years, but the government realized this was a huge drain on public time and resources, and so it sort of has steadily moved to the private sector. But what is actually needed from government is really the policy and support to make it happen. And if you look at the UK as an example, what we do see is that there is support in grants, but actually the process of getting forestry through a very complicated and convoluted planning process is one of the major issues, which is sort of really stopping the potential increase in afforestation. So I think it's a case of simplifying the process. It's obviously anything to do with land is complicated and has a lot of public opinion. So it is a complicated area, but it needs, I think it needs some simplification and government support to do that.
Angela?
Yeah, for bioenergy with carbon capture and storage, I think initial projects are going to need government support to get them off the ground. So a policy framework and some form of potentially a CFD but support that would enable the technologies to be viable. But the carbon cost from BECCS is going to be sub £100 per tonne. We're talking about less than £100 per tonne of CO2. And that's not a million miles off the carbon price in the market today. So if we factor in the fact that carbon prices are going to need to rise in order to achieve net zero, and that the cost of these technologies will come down over time, it shouldn't be far off these technologies being commercially viable. And certainly, you know, I think over time we can look at a mixture of government support, but as I say, also companies buying negative emissions, and the emissions from these technologies are not far off the carbon price in the market today.
Michael?
Yes, well, I'm happy to report that the government seems to be moving in the right direction on support for innovation and new technologies. The issue we have is that you know, technologies like ours are particularly capital intensive, and you know, unless the business models are there to support investment from industry, which they currently aren't, you know, it's hugely challenging to raise that sort of investment. So you know, they have announced recently all sorts of new sort of grant support mechanisms. Industry are now starting to engage a lot more meaningfully and starting to sort of make contributions to these grant-funded projects as well. We're seeing a lot of interest in sort of working with us. So that's all moving in the right direction. My particular favourites are these new systems. They call them SBRIs, and these are sort of government contracts as opposed to grants. Now, the advantage for a company like ourselves with this different approach is that these are contracts. It covers 100% of our costs. With a grant, at best, we only 75% of our costs is covered, leaving us the problem of finding the remaining 25% in the form of either investment from venture capitalists or from contributions from our industrial partners. So the new SBRI system, I'm a big fan of. We've benefited from a couple of those. Now we're currently working on a project to see if we can apply our process to capturing CO2 from the air, which is a really exciting area to be working in at the moment.
That is at least one legacy of Dominic Cummings. Maybe that it's not as bad as some of the others. In terms of other issues, I mean, clearly the whole question of this division between, if you want, more nature-based or more engineered solutions bring up a number of issues, and I was wondering if you could again, maybe in terms sort of talk about some of those challenges, if you want. I think some of the issues have already come up with regard to bioenergy, for example, with questions over, if you want, accounting, and so I think maybe we'll focus for the moment on that question of accounting and how do we actually know that we're getting the sort of size of the negative emissions that are promised. Maybe we'll start with Angela first to mix things up.
Yeah, it's a good question, and there are certainly supply chain emissions associated with BECCS, although they're certainly smaller in scale if you look at some of the other generating technologies. And actually, bioenergy has more stringent regulation of supply chain emissions than any other form of energy that's used. In order to qualify for support, we have to show that our supply chain emissions are less than a prescribed threshold. And so there's detailed monitoring, and all the information is made publicly available of the nature of the supply chain emissions. And actually, I think the point was raised about displacement. And if you factor in the fact that bioenergy is displacing gas generation at the moment, coal generation in the power sector, then overall the contribution is net positive. But it's quite right that this is an area of where there's stringent attention to make sure that actually you really are getting negative emissions and that the supply chain emissions are closely scrutinised and controlled.
Great, Michael?
Yes, I think accounting for stored carbon, I think, is a crucial aspect of this whole thing. There's little point in planting trees if the following year they're burnt down through forest fires or through somebody just basically getting the carbon credit, making a profit from that operation, then selling it to somebody who clears it and burns it in a biofuel sort of scenario. That really needs to be there really needs to be a trustworthy and internationally monitored system for monitoring these sorts of things. One of the advantages we have is that you can actually weigh the CO2 that you've caught, and because it's going into construction, you know, it's very well monitored through the fact it's a valuable item that you're buying. You're spending money per ton, so everybody is monitoring the tons. So it sort of all happens naturally. And once the CO2 is in this form, it's not going to come out again unless you put a lot of energy into it to actually release it again. So it's energetically downhill. So technology like ours is actually really quite good for monitoring purposes and guaranteeing the sequestration and abatement of that ton of CO2. But I think we really do need to have an internationally recognised system of trust. And I think blockchains are a particularly good way, a tool for monitoring these sorts of things. There's also a new coin that's been brought out as an organisation called Nori in the US that have a tradable blockchain controlled token. Alongside the tokens that they sell, they have a guaranteed sort of insurance system, whereby if over time it's discovered that a forest has been cleared or unfortunately burnt through a forest fire, they have an insurance policy to replace that ton of CO2 that was purchased by the customer. And it's those sorts of trust mechanisms that really need to be established, I think. And I think the insurance industry has a role to play in that.
David?
So Michael brings up some important point about forestry, and you know, it comes down to the issue, largely about the issue of permanence, because forests can come and go, as Michael pointed out. And this at the very start really left forestry out in the cold, particularly for the EU ETS scheme, for example. But it's really been the voluntary markets that have taken this challenge and have pretty well successfully put in place exactly what Michael wanted, which was a system where there is internal buffers built in, so there is an insurance policy which will allow, if the forest does inadvertently get burnt down, then there is carbon credits which are held back and then can be replaced, so that project is basically insured against that issue. And what we're seeing more and more is that forestry is being seen as it has to be part of the solution. So what we see is that forestry is an integral part of the New Zealand ETS, for example. It's an integral part of the Californian ETS. And it's only time before Europe wakes up, I think, to the fact that forestry has to be part of that solution. It has to be part of the compliance markets. I think the UK is an interesting position because having left the EU, it actually has a chance to do that. So that's one area of interest. I think forestry in general has always been a viable industry without carbon. But carbon coming into it will really help to give that push towards the afforestation that we need. And so a carbon price in a scheme, and most countries have some scheme for forestry carbon, is really important and will really help the use of forestry as a carbon sink going forward.
Great, thanks all. Maybe I'll ask one final question and then get to some of the Q&A as well, although we've already touched on some of the issues that have been brought up. but maybe that's to do with Angela's last slide, almost forgotten slide on on voluntary markets, which you just brought up, David, and that is maybe to push a little bit on this question of the potential role of offsets, and I guess the question of whether it is a bit of a double-edged sword, because there are questions over credibility. There's questions of kind of multiple systems, multiple efforts to claim that they're gold standards when they're not really gold standards, and so on. And so I guess maybe the question is, what is your view of the potential for these offsets and voluntary markets to play a role, and maybe discuss also what the time horizon for that would be. So the extent to which you're counting on that, and the extent to which you're, I don't know, maybe even actively trying to shape the stringency of those markets before playing in them. Maybe I'll turn it over to you, Angela, first, since it was your slide.
I mean, for me, there are two key issues around this, and one of them came up in the questions. Somebody quite rightly saying, doesn't this just let companies off the hook? If you let people buy carbon offsets and removals, doesn't it just let them off the hook in terms of their own decarbonisation efforts? And these things have to be complementary. Every sector, every company should do everything it humanly can to decarbonise its own emissions. That is absolutely clear. But if you look at the evidence of people like the Climate Change Committee, that just won't be enough. It won't be possible to get to net zero that way. So that's why we need carbon removals as a complement, but it must never be a way of letting companies off the hook for taking the action that they need to take to reduce their own emissions. It must only be complementary where people can't reduce their emissions far enough. Or in fact, some companies are seeking to buy carbon removals to tackle their historic emissions. And again, I think that's a really positive step. I mean, the other big issue around all of this is quality. And every few days we see articles talking about some of the lower quality carbon offsets and removals that people have purchased, and this brings the whole industry into disrepute when you have people purchasing negative emissions and making claims, and actually when you look into it, the carbon removal credentials of those things are not strong. But the answer to that is to have stringent standards in place, and there's more and more focus on making sure that there are appropriate ways of imposing standards on this market. We're involved in something called the Task Force on Scaling Voluntary Carbon Markets, which is a Mark Carney initiative. But the industry recognises that for credible people with quality products, we need to make sure that the market is well regulated, and that's both the supply of carbon removals and also their use, so that we maintain the reputation and the credibility of the industry.
Yeah, thanks, Angela. David.
Thanks. I think Angela's put it very succinctly, the two issues. And I think that the voluntary credits really, I think, have moved tremendously from where they were. They still do have some quality issues because, exactly as Angela said, not everyone is applying the best standards. But actually, if you look at the sort of top standards, they are pretty consistent with compliance markets. They are well regulated, and of course, like anything, there will be some exceptions which will cause some public outcry and maybe lack of confidence in the system. But I think we are a long way along from where we were, and I think the voluntary markets are growing. And I think it's really the case that the voluntary and the compliance markets are sort of almost merging together, and there will be a time when actually I think they'll be at the same standard and can be traded equally.
Great, and then finally, Michael, any thoughts?
Yes, I mean, I highlighted the fact that we needed international standards, and I think that's absolutely crucial. One of the things that I'm concerned about, and I've already been seeing this happen, is you can buy a cheap carbon credit one part of the world and then trade it on another market where it's more expensive, and you can actually game the system. That sort of behaviour, I think, is really bad. And also, Anne just used the word quality. in terms of a carbon credit. They can only be one carbon credit, and that has to be 1 ton of CO2 has been stored somewhere. There's no issue of quality of that. Either it's stored or it isn't. So I think this is why a standard, I think, is really necessary in order to guarantee that if you buy a ton of CO2, it is a ton of CO2 stored for forever. And I think that is really crucial. And again, I stress the word forever, because you know, you've got characters like Nigel Farage, for instance, getting into forestry type things. Now, Nigel Farage isn't known for his belief in any climate change issues. So why is he actually part of an organisation that's selling carbon credits? It's obviously in it for the money. So you know, we have to be really careful of these sorts of behaviours and ensure that every ton of CO2 credit that's sold is actually delivering what it says it is.
Great, thanks everyone. Let's turn to at least you know, skim the surface of the many dozens of questions that we've received. One thing that actually did strike me, which I'm not sure we've really dealt with as much, is questions beyond CO2. So there was a question to do with, you know, biodiversity, to do with livelihoods, and so on. And I wonder if maybe you could, you know, anybody willing, David most obviously, but I think Angela and maybe Michael as well. You know, what are the, if you want, the non-CO2 either benefits or challenges associated with your, you know, your preferred options?
Happy to take that on. Certainly with forestry, the benefits from commercial forestry, of course, is generally employment. Is one of the largest, and it's always employment in rural areas. And if you look at anywhere in the world, including places like the UK, it's rural employment which is the issue. So I think that sort of is where forestry is important. But obviously, forestry in general will have a range of other benefits, which include, you know, water quality, particularly for flood control, for reservoirs. It involves, and maybe more controversially, biodiversity, because in today's commercial forests are very different from the 80s, where it was sort of blanket Sitka spruce across the country. And now it is very well regulated in the fact that you do have to have open spaces, you have to have broadleaf areas, you do have to have conservation, things like wildlife and bird counts have to be done, etc. So we've come a long way from where some of those controversial forests were in the sort of 70s and 80s. And I think around the world, the trend is for forestry to be more regulated and to be ensuring that it's providing a whole range of benefits to society, whether it's in environmental or whether it's in recreation. So I think I'll stop there, but I think forests offer so much more than just timber production and carbon storage.
Angela?
Yeah, I echo that in terms of the benefits of forestry. And when we're looking at our forestry sourcing policy, then looking at issues around sustainability in its broadest sense, including biodiversity, is key when we look at where we want to source our forestry from. So it's the sustainability and also echo the point on employment benefits and the employment benefits of this. We're looking at creating thousands of jobs in the north of England as part of the development of this project, and stimulating new technology would be the other one for BECCS. And actually, I think one of the nice characteristics of voluntary carbon markets is they give people the opportunity in buying carbon credits to select additional characteristics that matter to them. That's the way this market is going to grow. So people will say, it really matters to me that I want to purchase a ton of CO2, but alongside that, I'd like to do something to stimulate biodiversity, or I'd like to do something in developing countries, or I'd like to do, and it enables people to think about the characteristics of carbon removals and the other benefits that they want to support alongside the core carbon removal.
Yeah, that's a great point. Michael, do you want to add?
Yes, well, our sort of angle on this is around the circular economy. So, you know, our technology is quite unique and to be frank, problematic, because it touches on so many different aspects of industry. So we're starting off with mines. Now, one of the issues with mines is that they're not known for their environmental sort of positive environmental impacts, and more in the mining investor community, they're looking at these environmental impacts in quite negative ways. And what with the development of electric vehicles and the use of batteries for both energy storage and for transportation, the demand for crucial metals like nickel and cobalt are going through the roof, and this is going to have to mean more mining, not less. And those new mines need to be sustainable, both environmentally and also socially as well. So there's a lot of pressure currently on the mining sector to clean up their act. And this is where our technology sort of really helps, because potentially our technology is a more sustainable route to extraction of metals. It's almost more attractive as a metal extraction process than it is for a carbon capture process, ironically. And these sort of things are starting to become quite clear to us. So that's really important. But then you're creating products that, again, feed industry with raw materials. And these raw materials are actually removing the CO2 from their processes, making them more environmentally sustainable. But then the construction sector, who are in desperate need of having to reduce their embodied emissions in the products that they use, as well as their operations. And we can do both. We can remove CO2 emissions from the cement manufacturing process. We can then use the byproducts for that in the construction materials, displacing some of the concrete that they would otherwise have to manufacture. So there's some really interesting sort of positive benefits that mount up with our technology, which is really, really encouraging.
Great, thanks, Michael. Maybe as a very last 30-second each question, I think you're all quite optimistic over the maybe 5 to 10 year time horizon as to the viability. But maybe you could just say, again, in 30 seconds, 45 seconds, what is the biggest barrier over the next few years that you see as needing to be overcome?
Can I start on that one?
Yeah, please, Michael.
For us, it's investment. We've got some good engagement with industry, and we've spoken to Drax in the past, and they were very interested in our technology, but unfortunately we weren't further enough down the path to be of use at that time. We hope to remedy that, but the only way you can remedy that is through investment. So venture capitalists are quite risk averse, shall we say? And when you've got a technology that's trying to appeal to markets that are very capital intensive, very risk averse, and very slow moving, it's not particularly attractive to your standard venture capitalists. So what we need is venture capitalists with balls. And not too many of those around, unfortunately.
Great, thank you. I should move on very quickly to David, and then give Angela the last word. Yeah. David, very quickly.
Thanks, David. So what we do see is an increasing amount of capital being made available to forestry, because it's seen as a very positive way of both from a return point of view, but also from a net zero point of view, as shown by that chart that you showed. And so I think the biggest sort of impediment for the growth of forestry is really to do with government policy and making available the use of unproductive land, which is sort of changing from the agricultural side as that sort of comes out of these sort of big, large agricultural policies, and should be made available to the best use, which is often forestry.
Great, thank you. And then Angela, last quick word.
So 2 things: a government support framework to get initial projects off the ground. Over time, it should be able to do it on the basis of market, but for the first projects, you're going to need government support. Second thing is having the CCUS infrastructure in place, the offshore stores and the pipelines. And again, somebody asked this in the questions. Government has said it's going to have the first 2 clusters with CCUS offshore storage in place by the mid-2020s.
Brilliant. Thank you to the panel. And maybe just for the final word, I'll turn it over to Ian Marcus. And thanks to everyone on my behalf.
David, thank you. As president of the Cambridge University Land Society, on behalf of the over 300 people attending today's webinar, thank you to all our speakers today for their insightful, thought-provoking and visionary comments on the topic of carbon capture. We received over 50 questions on the Q&A and the chat line, and obviously not a chance to answer them all, but just shows the interest and inquisitiveness on the subject. And we will circulate those to our speakers, and hopefully they may respond to some of those. So thank you for your engagement and involvement. The technology, as you've heard, is just moving so fast, but it remains vital, I think, to ensure we continue to achieve as best we can that balance between what is socially responsible, environmentally friendly and economically viable, whilst endeavouring to achieve our target of net zero. Can I once again thank Savills, and in particular Ellie and Roger, for their continuing support and sponsorship of this series of ESG lectures. It's really appreciated. In fact, the series has been so well received, with literally thousands of participants. There will be a second series beginning in the new academic year, again in partnership with Savills. And in recognition of this and the broader significance of social impact and sustainability, Culls has decided to establish a new forum under the board to focus on this subject. And I'm delighted to confirm that my board colleague, Ami Kotecha, without whose enthusiasm and commitment this programme would not have been the success it has, will chair that forum. This is the Society's last webinar of this academic year, and despite all the challenges, we've hosted nearly 30 events, and we're already planning a full programme of lectures, site visits, careers fairs and networking events. Hopefully, fingers crossed, that'll all be live. And we look forward to continuing to promote the university's departments of land economy and architecture, educating our nearly 1,000 members, and doing all we can to support the student body and provide a forum to network. So thank you so much for joining us today. May I reiterate our special thanks to the two Davids, Angela and Michael, for their outstanding contributions. And I wish you not just a good day, but a good summer, and look forward to seeing you all again in September. Thank you and good morning.